If you have ever been intimidated by the structure analysis, fear no more. By the end of this video, shear force and bending moment diagram will be your new best friend in engineering design. What is shear force? Shear force at a section of the beam is the internal force that acts perpendicular to the length of the beam. And bending moment at a section of the beam is the internal moment or torque that resists the bending caused by the external applied loads. And what is the relationship between the shear force and bending moment? The shear force at a section can be thought of as the rate of change of the bending moment. When the bending moment changes, the shear force also changes. These both are interconnected. In the beam, maximum bending moment occur where shear force change sign from positive to negative or vice versa. Means the maximum bending occurred at a point where the shear force value is minimum or zero. So in this video lecture, we will be drawing the shear force diagram and bending moment diagram that are widely used in the structure analysis and design subject of the civil engineering. So with the help of the question, we can easily grab the concept behind drawing the shear force and bending moment. So let's get started. So we have the free body diagram of the question. We have the beam and we have the support action and the applied loads acting downward having the intensity of 5 kN and 7 kN, and we have this distance from this support action to the this unit load, which is 3, and the distance between the two unit load is 6 meter, and distance from this unit load to this point, this support action is 1 meter. So we have the support action R1 and R2. We will be drawing the shear force and bending moment diagram for this question, which is the free body diagram of the beam. So the first step is to find the support action value. So this is the determinate structure. We have the total number of unknown is 2, and we have the equilibrium equation 3. So equilibrium equation is more than the number of unknown. So this is the determinate structure. So we can easily find the value of R1 and R2 by using the equilibrium equation. So the first step is to find the value of R1 and R2 with the help of equilibrium equation. We have 3 equilibrium equations: summation of f of x is equal to 0, summation of f of y equal to 0, summation of moment at any point equal to 0. So we have no force on x-axis, so we will not take that summation of f of x equal to 0. We have forces along the y-axis. We will be using the summation of f of y along y-axis equal to 0, summation of f of y equal to 0. So I am taking the upward forces will be taken as positive and downward will be taken as negative. So we have the upward forces will be taken as positive and downward forces will be taken as negative. So for this, R1 plus R2 minus 7 minus 5, so equal to 0. So after adding these minus terms, so R1 plus R2 minus 5 minus 7 will yields minus 12. So shifting this 12 to the other side, it will be positive. So R1 plus R2 equal to 12. We have two unknowns, so we will be naming this equation as equation number A. So now the second step is to find the in this step, the first step, the second part is to take the moment at any point equal to 0, because we need to find the value of R1, R2. So take the moment at this point or this point. So I am taking the moment at this 2 point. So I will find the value of R1 easily. So it is very simple that I am taking the moment at this point equal to 0. For this, I am taking the positive clockwise moment as positive. So all the clockwise moment at this point producing will be taken as positive, and all the anti-clockwise moment will be taken as negative. So here you can see the calculation that R1 into this perpendicular distance, which is 3 plus 6 plus 1, means this is a force and perpendicular distance is this. So R1 into 3 plus 6 plus 1, which is 10, and this 5 into 6 plus 1, and this producing the anti-clockwise moment. So I am taking this as negative because I took that I taken that the positive value will be the clockwise moments only. So this force producing anti-clockwise moment, so I am taking as negative -5 into 6 plus 1 is the perpendicular distance up to this point. Now this 7 kilonewton also producing the negative moment, means the counterclockwise moment. So I'm taking as -7 into this perpendicular distance 1. So by simplifying, we will get the R1 into 10 -5 into 7 -7. So after simplifying, we will get the R1 into 10 is equal to 42. Shifting all these to the other side. And now I will get the value of R1 by dividing 10 both sides. We will get the value of R1, which is 4.2 kilonewton. Now putting this value in this equation, we will find the value of R2 support reaction 2. So putting 4.2 plus R2 is equal to 12. This is the equation A. I only did that. I put the value of R1, which is 4.2, I found here. So by doing calculation, we will get the value of R2, which is 7.2 kilonewton. 7.8 kilonewton. This is the first step to find the support reaction. Now without finding the support reaction, we cannot find the shear force diagram and bending moment diagram. Now with the help of support reaction, we can easily we found the value of R1 and R2. Now we can easily draw the shear force and bending moment diagram. Remember this shear force diagram always be drawn by with the help of the free body diagram. So this is the graphical method, not the section method. There are two types of method. With the help of these two methods, we can easily draw the shear force and bending moment diagram. The first method is the equation method. We will cutting the section, different section. Then by finding the equation, drawing the equation, we can easily draw the shear force and bending moment diagram at any point. Now this video is about the graphical method, means the area method. We will need this free body diagram for the shear force. So I am drawing the same beam here, and we have found the value of R1 and R2. Now I am drawing the same length of the beam here. Now I will be drawing this y-axis, which represent the shear force value in kilonewton. Because all the forces are given in the Newton, shear force is the kind of force. So the force unit is here kilonewton. So I will be taking as kilonewton. Now remember this, from this point upward value will be taken as negative, positive, and downward value will be taken as negative. And this point will be taken as origin, means 0. So the upward will be positive and downward will be negative values. So here you can see that. Now we will be drawing the shear force. So before drawing the shear force, you first draw this picture, this diagram properly. So draw a vertical line at any point where forces changes. So here the one point is this, that force changes, and another point is this, the force changes, and third is the last point. So I am drawing the vertical line. So this is the very essential step for drawing the shear force and bending moment diagram. So I am drawing the horizontal line, vertical line where the forces changes. At this point force changes, and at the last point which is this. So the first step is that I am taking all the upward value as positive, and downward direction forces will be taken as negative. So remember this 4.2, which is the support reaction value, acting upward. So I will be moving from this 0 to the up to 4.2 kilonewton, drawing a line. So here you can see that I will be drawing this line. So I am drawing this line up to 4.2 kilonewton. So now see this free body diagram, that from this point up to this point we have no force. So means that we will be moving straight horizontal. So means we will be moving constant 0-degree curve. So we draw up to this point, we draw this line because there is no force, so we will be moving to this. Now we have this in this point we have plus 4.2. And this is at this point we have -5 because it is downward in direction, so -5. So add plus 4.2 minus this 5, it will yields minus 0.8. At minus 0.8 lies here, so I will be drawing this vertical straight line. So here you can see that I draw the vertical straight line at minus 0.8 intensity. So you can see the value of 0.8 and it is below this line, which is negative, so it is minus 0.8. so also see this freight bar diagram, we have no force from this point to this point, so we'll be drawing the straight horizontal 0 degree line. So you can see that we draw the straight horizontal 0 degree line, constant line. Now we at this point we have the force value is minus 0.8. This value is same here, minus 0.8. So in this point we have 7 kilonewton, which is downward, so this is also minus 7. So minus 7 and minus 0.8 yields minus 7.8. so we will be drawing the line at this point minus 0.7 minus 7.8 minus 7.8. so we draw a line and give the value is 7.8, which is minus in nature, negative in nature. So from this point to this point we have no force value, so we'll be moving to the constant and we draw this. So this value is same here, which is minus 7.8, and we have this support reaction value which is plus 7.8, and if we add this value and this value, it will yield 0 value. So we will be drawing this vertical straight line, so we will be meeting at this point. So this is the summary of the shear force diagram. We will draw the shear force diagram with the help of free body diagram. So this is the concept behind drawing the shear force diagram. Now in next slide we will be drawing the bending moment diagram with the help of this shear force diagram. Remember this, with the help of this shear force diagram we will be drawing the bending moment diagram. With the help of free body diagram we will be drawing the shear force and we drawn, and with the help of this shear force diagram we will be drawing the bending moment diagram. So here you can see that in with the help of shear force diagram we can easily draw the bending moment diagram. For this we need few things. We have this distance as mentioned in question, and the 6 meter and 1 meter, you can see that. So now we have we need this, we need to find this area and this area, which are the rectangles. It can be easily found the base into height. So we will be first take this beam of same length, and this y-axis line, it now represent the bending moment, because we will be taking now as a bending, we have to find the bending moment, and the unit is kilonewton meter, because it is a moment unit is newton meter, kilonewton meter, or mega pascal, mega newton meter, etc. So we have the kilonewton meter, so we'll be taking this. So this point represent the 0, upward value represent the positive, as same as in the shear force diagram. So downward value lines represent the negative values. So first step is same as for the like the shear force diagram. We did this, wherever this shear force changes, draw the same line. So we will be drawing the same vertical line at this last point also. Now we need to find this area 1, area 2, area 3, because this is graphical method. For graphical method we need to find the area of the shear force diagram, and then we can easily draw the bending moment diagram. So the area 1 is height times base, 4.2 into 3, which yields 12.6 kilonewton meter, and the area 2 value will be 0.8 times 6, which yields 4.8 kilonewton, and area 3 will be 7.8 into 1, which yields 7.8 kilonewton. With the help of these area we can draw the shear force diagram. Here you can see that we will be starting from this 0, and we have this area 1 value is 12.6, which is upward from this line, means it is positive. So I will be marking 12.6 point here, because positive, so I will be marking here positive point. So I draw the positive point. Now I join this origin to this point, because you can see that this is 0-degree curve. So we will be making the first degree curve in bending moment. This is the concept behind how to draw the bending moment from the shear force. Here you can see this is the 0-degree. In bending moment it will increase 1 degree. So here from 0 it become 1 degree line. I made this point, which is 12.6 kilonewton. Now the second step is that it is area 2 is 4.8, which is below the main beam line, which is negative. So 12.6, I will be subtracting 12.6 minus 4.8. Why minus? Because it is below the main line, means this area is negative. So 12.6 minus 4.8, it will yields the 7.8 values. I subtract these values and get the 7.8. It is positive. So I will be marking this point 7.8 also, and joining this is a 0-degree curve. So we'll be joining this will be the first degree curve. So you can see that we join this line, this point to this point, by a linear graph, linear line, and this value is 7.8. How can we get? By subtracting 12.6 by this area minus this area will yield 7.8, and we join this and this point by a line called linear line. Now the next step is to subtract this 7.8 and this 7.8 area 3, means this point minus this point. Why minus? Because it is below the main line, so it will occur in negative. Area 3 will be minus. So 7.8 is plus, and minus this 7.8, it will yield 0 value. I will be marking as 0. So here you can see that we mark as 0 and meet this point to this point. It is 0-degree line, so the bending moment will be first degree. Here you can see that we draw this bending moment diagram with the help of this shear force diagram. This is all about that how to draw the bending moment diagram from shear force diagram. You can also do reverse that. With the help of bending moment you can also draw the shear force. These both are interconnected, interrelated. If we integrate this shear force diagram, we can easily get the bending moment diagram. If we derivate this bending moment, we can easily get the shear force values or shear force diagram. So I hope you got the concept behind how to draw the shear force and bending moment. With the help of free body diagram of the beam, we can draw the shear force diagram, and with the help of this shear force diagram we can easily draw the bending moment diagram. So I hope you got it. If you have any question, write in comment, I will answer. So thanks to everyone.